Hi folks, welcome back to the Integrals Review. So in this video we're going to take a look at example number 2, which is under that same category of what is an integral. So again, when we see this integral notation, specifically the definite integrals, we're really looking at finding the area of a curve, okay? So let's point out a few things that are similar to the last example. We have an a value at the bottom, that is our starting bound. That means on our graph that x equals 1 is where we want to start finding the area. Our top bound is 9, which means that we want to stop at an x value of 9. And then our answer should represent the area between that curve and the x-axis. So this area right in here, okay? All right, so a few things about our answer. Let's predict a few things here. This is going to be positive, okay? It's positive because it's above the x-axis. And so we're going to have a positive area or a positive number as our answer. The other thing I want to point out to you is that this shape is not symmetric. Meaning that I can't use the shortcut I finished the last video with, which is find half of the area and double it. I'm going to have to just use brute force and integrate and then plug in both bounds, okay? So let's get started. I'm going to go ahead and copy this problem down here. So we've got the integral from 1 to 9 of x minus 1 over the square root of x dx. All right, so I know that at this point you're probably finished with 150. Hopefully it's still fresh in your brain. And one of the things that we finish with in 150 is the idea of U substitution. And because it's the last thing we learn, sometimes that's the first thing that we try in our next course, okay? But I want this to be an example where we go back a few steps before we even knew what U sub was and really use our algebra to help us simplify things so that we can integrate using basic things like the power rule. So I'm going to do a few things here. And the first thing I'm going to do is this square root of x, I'm going to change it to x to the 1/2 power. And that's a really important change for you to know how to make, all right? So I have the integral from 1 to 9 of x minus 1 over x to the 1/2 dx. The second thing I'm going to do, still with this, is I'm going to take this and I'm going to write it as the power of x to the negative 1/2, okay? So that is going to give me a statement like this. The integral from 1 to 9 of x minus 1 times x to the negative 1/2 dx. And the last thing I'm going to do to algebraically simplify this is I'm going to distribute that x to the negative 1/2 to the x and the negative 1. So let's see what we get when we do that. The integral from 1 to 9 of x to the 1 times x to the negative 1/2, all right, so I just multiplied, minus 1 times x to the negative 1/2 dx. And one final algebraic rule that is good to know is that when we are multiplying terms like this and they have the same base, then we're going to go ahead and add our exponents. So what's that going to give me as a good place to start? The integral from 1 to 9 of x to the 1/2, because 1 plus negative 1/2 is 1/2, minus x to the negative 1/2 dx. Okay, so a whole line of algebraic simplification, all right? That is going to be something that is really key to your success in Calc 2, is being able to simplify things algebraically, okay? The radical to the power, knowing if you add exponents or subtract them or divide them, those are all important things, okay? Because now we get to a problem that is just the basic power rule. So when we take our integral, and let's do this step by step, let's use the power rule for the first term. So x is to the power 1/2. 1/2 plus 1 will give us our power. And then whatever we get, we're going to take the reciprocal of that to put that as the coefficient. Okay, so that's the integral of the first term. Minus, let's do the same thing for the next term. So x is going to be to the power of, let's see, negative 1/2 plus 1. And then I need the reciprocal of that as the coefficient. And then I'm going to plug in 9, and I'm going to plug in 1. Okay, let's simplify this here. The first term, x is going to be to the power of 3/2. And so then my coefficient is 2/3, the reciprocal of the power. Minus, in the second term, the power of x becomes 1/2, and the reciprocal of that is just 2. And I'm going to plug in 9, and I'm going to plug in 1. Now, a lot of our exams are going to be non-calculator, so I really want us to know how to do this next step, which is how do we evaluate things that have fractional powers without a calculator, okay? And to answer that, let's go ahead and rewrite this with our radicals. So we'll get 2/3 times the square root of x cubed minus 2 times the square root of x. And I'm going to plug in 9, and I'm going to plug in 1. So when I rewrite these, okay, let me write this off to the side. This is an important rule, that x, if I have a fraction in the power, all right, we'll consider the top number as the power, the bottom number as the root. That means we can rewrite this as the root goes on the outside and x to the power goes on the inside, okay? I would say that this is one of the most important algebraic things that you can know for calculus. All right, let's keep on solving this problem here. So this gives me 2/3 times the square root of 9 cubed. I'm going to write that as 9 times 9 times 9, minus 2 times the square root of 9. All right, so this is my f of b. I'm plugging in 9 for my x's, minus, let me plug in 1 now. 2/3 the square root of 1 cubed minus 2 times the square root of 1. And that is my b value plugged in. Okay. All right. So this first term, this 2/3 stays, but the square root of 9 is actually something that you know. So the square root of this 9 is 3. The square root of this 9 is 3. And the square root of this 9 is 3. So really, I have 3 times 3 times 3, minus 2 times 3, okay? Minus, the next one is pretty straightforward because 1 is an easy number to take the root of and to raise to a power. So we just get 2/3 minus 2. All right, let's see what happens when we cancel some things. Well, this 3 and that 3 could reduce. That's a good start. And that will give us let's see, 2 times 3 times 3 is 18, minus 6, minus 2/3 minus 2. And that's going to give me 18 minus 6 is 12, minus 2/3, and then make sure you distribute that negative sign to make it a plus 2. That's going to give you 14 minus 2/3, or if we make a common denominator of 3, we'll get 42 minus 2 over 3, or an answer of 40 over 3. Okay? Now this number is positive, which is really good, because when we looked back at our original question, we actually had a positive area. We had that area above the x-axis. Okay? So that's where we're going to stop for this video. Come on back to do a few more problems on just basic integration, using all the different rules without having to worry about plugging in for definite integrals. Okay? I'll see you there.